Hello everyone. Today we are going to solve the Leetcode question 3170 lexicographically minimum strings after removing stars. Let's see what the question says. You are given a string S. It may contain number of stars. Your task is to remove all the stars. While there are stars, do the following operations. Delete the leftmost star and the smallest non-star character to its left. If there are several smallest characters, you can delete any of them. Okay. Return the lexicographically smallest resulting strings after removing all the star characters. Okay. The question wants us to return at the end the lexicographically smallest string that we can get. And for that, we have actually very less options to perform. Like it is fixed that we have to remove the leftmost star first. We have to remove the smallest character. The only freedom we have got to choose is that if there are several characters, we can delete any of them. This part we only need to decide in our program. Let's see this with an example. Like in case of the example 1, double A, B, A and a star. In this case, for removing the last star, we can remove any of the three A's. Here we need to decide which A we should remove to get the lexicographically smallest string. As we know that lexicographically smallest string is the string which comes fast in when the strings are arranged in an alphabetical order. So for getting the lexicographically smaller string, we don't want to remove the small characters which come fast. So we will be removing the smaller character from the right side, which is the last A. When we remove the last A, we get the remaining string double A B, which is our result. And in case of second example, we don't have any star, so we don't need to remove any character, and the result is ABC only. Let's see this question with another example. In this example, we have the given strings A, B, C, double A, B, 4 stars and a B. So according to question, we can remove the leftmost star first, and for removing the leftmost star, we will be taking the smallest character towards its left, and those are the three A's. And as we have decided earlier, we will be removing the rightmost smallest character. So for removing this star, we will be removing this A. And for the next star, we will be removing this A. And for the third star, we will be we have only one option actually, the first A. And for the last star, we can remove any of the B, but we will be removing the rightmost one. So we remove this one, and at the end, our result is B, C, B, which will be our lexiconically smallest string after removing the 4 stars. Now the question is that um, for removing the stars, let's say we want to remove this star, how we will know that which character we need to remove? Like we know that we will be removing the rightmost uh, smallest character, but how we will know the position of the character? The brute force approach, if we go through the brute force approach, we will be traversing the string from left to right. Whenever we will see a star, we will again traverse back and check for the smallest character. And then remove it. But the problem in this approach is that the constraint says that the length of the string can go up to 10 to the power 5. And the brute force approach, if we go through the brute force approach, our time complexity will become big of n square, which will clearly give us time limit exceeded. So we need to optimize the part of choosing the character, the position of the character, which we will be removing. For that, we can actually take a priority queue while traversing from left to right. We will be storing the characters we see into the priority queue. Uh, First we store A, then B, then C, then again double A, then B. Then when we see the star, we will be popping out the top character of the priority queue, and that should be removed. Now, if we do the priority queue, it will be looking like triple A, double B, C for the first star. And when we see the star, we will be removing the smallest character A. From this, we can see that we will be removing the A. But the question is, we don't have the position of the A in this priority queue. Like we get the A, but which way, which A we are getting, we cannot determine from this priority queue. So we need to store the index position of this character into the priority queue as well. So for that, we have several methods, but I'm going to show you a method which no one else is going to show you. So see properly. For storing the character as well as the index of the character into the priority queue, we can store it as a pair, but I'm going to show you a method where we can merge two datas into a single location. Let's see how that works. First, for that, mark this 10 to the power 5, which means the maximum value that the index can get um, is 5 nines. This is the maximum index we can get in this question. And for character, we can take those characters from 0 to 25. So let's say for the highest values, like for Z occurring at the index 5 nines, we can merge those two and get a number 2 5 0 and 5 nines. And when we do the mod 10 to the power 6, we get the value 5 nines. 1, 2, 3, 4, 5. And when we divide it by 10 to the power 6, we get the remaining part. For doing this, we can have the formula like the character value into 10 to the power 6 plus the index value. Taking this same example, if the character is Z, then the value is 25, and when we multiply 25 with 10 to the power 6, we get 25, then 6 zeros, and after adding the index, which is 5 nines, we get the value 250 and 5 nines. But the problem here that occur is, in this case, if we take this example and encode it in this formula, we will get the value for the first A and index 4 is for A we will be having the character value 0, then into 10 to the 6, that remain the same 0, plus index 4, which will give us the value 4. And for the second element A3, we will get getting 3. And for the third element A at index 0, we will getting simply a 0. But while inserting this element into the priority queue, the A with index 0 will come at first, then A with index 3, and then A with index 4. But we want that the A with index 4 should come first, then the A with index 3, and then the A with index 0. Here we cannot simply reverse the priority queue, as reversing it will bring C to the first, then B, then A. We only need the index part to be reversed. So for doing that, we can do a simple change to a formula, which will be, we will be subtracting the index from 10 to the power 5. Why 10 to the power 5? Because this is the maximum value we can take for the index. And after the updated formula, we get the values for these elements are, we will be getting the value, these values for the elements we have taken above. And we can see that these values are also in the order we needed, from smaller to greater, for the priority queue. Now uh, we have done the push operation for the priority queue. We will be implementing this formula and pushing the values into the priority queue. But while popping, we will be getting the values 00496 for character A and index 4. Now we need to get another formula to split these values into the index and character part. And the formula is value divided by 10 to the power 6 will give us the character, and value mod 10 to the power 5 will give us the index. Now let's take an example for this formula. Let's take B5, which is 10495. And if we do the formula on this, when we divide this number by 10 to the power 6, we get the value 1, which is the character, which represent the character B. And when we take the mod of 10 to the power 5 for this element, we get 495. It gives us the index element, no doubt, but this is not the actual index element. We have to actually then remove this 10 to the power 5 part from the index. So after this, we then subtract the value which we got from the mod, after the mod, to get the actual index. Now putting that into the formula, 10 to the power 5 minus value percentage 10 to the power 5 will give us the actual index. This part is giving us the index component which we stored into the priority queue, but to get the actual index, we need to subtract it from 10 to the power 5. Now let's see this implementation in the program. Coming to the program, first we have taken the length of the string given. Then we made a boolean array of the same length as the string. This we need because we won't be removing the character one by one. We will be marking the index of the character which we want to remove, and at the end we will merge all the character which we don't want to remove, and that will form our resultant string. And the priority queue which we will be using here, um, first we got the character, then we check that if it is not a star character, then we implement the formula we have decided in the previous part, that is the character part into 10 to the power 6 plus 10 to the power 5 minus the index. Then we add it to the priority queue, and if we get to see a star instead of the normal alphabet character, then we want to remove the star character and the top element of the priority queue, the element which we get from the priority queue. So for removing that, we mark the index. Like if we get to see the star at index 4, in this case 4, then when I equals to 4, there is a star and the else condition is triggered. Then we mark the boolean array of position 4 equal to true. Here we are taking true for those index which we don't want in the resultant string, and then we determine the index part which we want to remove. So we get the value from the priority queue, then mod it with 10 to the power 5, sorry, 10 to the 6, and then subtract the mod value from 10 to the 5 to get the index value, and then we mark that index as true, or we won't be using that in a resultant string. Then finally we take a loop, and the position where the value is not true, we append that character into our result, and finally we return our result. Now let's submit the answer, and it is accepted. Thank you. Subscribe.